Okay, so thanks everyone. Thanks for having me here. And I'd like to talk about the metaRbolomics toolbox in bioconductor and beyond. And this is really an effort by a large number of people from all over the planet. So to start briefly, some background here. Most people probably know the statistics language R. What is less known is that R just celebrated the 20th birthday. So 20 years ago, this CD-ROM was shipped around by people, probably signed by some of the core team. So it has a really good history, and it's also in the popularity contests of some of the programming languages among the top 10 or top 12 currently. The core language itself can be extended by packages, and this is really the opportunity where people in different fields can contribute additional functionality, just like in many other programming languages as well. Bioconductor is, well, one of those package repositories where people can host a collection of packages. It has now the primary citation, more than 12,000 citations, but it's really more than just a package repository. They are hosting, of course, the website, extensive developer infrastructure, including the version control. There's a build farm for the individual packages to check that they actually work. A large set of workshops being held all over the place. And if you want to dig back into that version control, you actually see that Robert Gentleman nearly 20 years ago did one of the first commits here on some sequence annotation functionality. So Bioconductor itself will have a 20th birthday sometime next year. And together, the R and Bioconductor world is really at home everywhere. It doesn't really matter on what type of operating system you are. The Bioconda packaging system also has a very nice way to install the software, independent of which operating system you're on. And then it really scales from your laptop to HPC clusters to the cloud, can be packaged in containers and so on. So really has a lot of, let's say, batteries included, an ecosystem. You can write scripts that do a particular analysis. There is a development environment that can run locally or as a server environment. You can write vignettes which entangle the computation and an explanation of what's going on there to provide you with nice reports and documents. There are notebooks where you can do something very similar, but even change the calculations that are done. There is interactive learning environments in a package that helps you to build courses and training material. And you can also write nice user interfaces using Shiny that are running either locally or again as a web application. So R, the language, can interface with functionality provided in external libraries that could be written in any of the popular languages we have out there. And then in turn, you can embed R functionality or an R interpreter and call that in Galaxy workflows or KNIME workflows and so on. So this talk that I'm giving here is really a community effort that started off 4 years ago at the Metabolomics Society conference in Dublin, where we had a workshop being held showcasing some things you can do in R and Bioconductor. And afterwards, we had the idea, well, just write up a short review to show how to combine a few of the packages. Now, what happened some years later is that nearly 20 authors were providing a review of nearly 300 R packages, not only on Bioconductor, but also elsewhere, and published that as a review in the MDPI Metabolites. And during the journey, we had workshops and hackathons following the 2016 one that was in Wittenberg in Germany. We had one earlier this year, just probably one of the last workshops before the shutdowns all over the planet. And we hope to have another one next year in Germany. Let's see how that works out. So at the beginning, you have the question how to find metabolomics packages in R. So if you go to CRAN, the Comprehensive R Archive Network, then you find the task views that are manually curated documents with a maintainer, and that would be writing on how you can do things, and they would have links to the actual packages in between. If you look at Bioconductor, they have the BioC views infrastructure where I have tags and keywords and stuff, including some lipidomics in some places. And those tags are maintainer curated, and some of the packages are also put together as workflows. And if you go to GitHub, there is also a way to have topics. So you can actually also search for R and metabolomic stuff. Unfortunately, the number of repositories that make use of that functionality is rather limited at the moment. So if you look at the landscape of data processing and analysis you find in metabolomics, and very similarly also in lipidomics, it really goes from the raw data that you have from some assay to the processing and annotation of stuff, and then it gets to where you want to have the interpretation and analysis in the experimental context. That is the different statistics that are available not only for the life sciences, but also from other packages in R. And then where it becomes biochemically really interesting is the network analysis and biochemical pathway information. And all of that in some packages is spanned by multifunctional packages or workflows, which try to put together a set of nicely integrated packages and give you a decent interface to them. So in the review we were putting all these functionalities into tables, giving you links to the packages and where they are hosted. And in the remaining text, we also had some explanation of what's going on in there. So that would be a fantastic place to start when you start your PhD. Go to that review and have a look what's out there. What you also get in the R world is that each package has a description, which well describes the metadata for the package, including authorship and some short description, but also the dependencies. And already a few years back, somebody was doing an analysis of these dependencies, for example, on the CRAN repository and on Bioconductor. And what they concluded back then was that the Bioconductor packages were much nicer integrated, much closer integrated, probably because they are all dealing with life sciences in some form, but also because the Bioconductor team that I mentioned in the beginning is actually making an effort to help people integrate and collaborate between the packages. So what we have done as part of the review, we also did a smaller scale analysis of the dependencies that you find in the metaRbolomics network. So you can actually have a look at some of the packages and also see what is the functional or dependency neighborhood of that package. And that was not just a once-off analysis, but the script is also available in the article. So you can rerun that in a year's time and it gets updated. As a follow-up to the review that we wrote, because it's Creative Commons licensed, we took the same basically text and tables and everything and put that into a community maintained book hosted on GitHub. So it's using continuous integration. It's available as part of the R for mass spectrometry initiative that I'll come back to in a moment. And if you have any contributions, you're more than welcome to contact us, and we'll try to get that incorporated into the book and text, or you can send a pull request. So available in different formats as it is natural for Bookdown, as an EPUB book, as PDF or HTML. Now, what packages do we have in Bioconductor for metabolomics processing? And if you go to the BioC view metabolomics, then you see several packages that are already building upon each other and integrating nicely with each other. And they were written by different labs. But we saw that it's time for a new basis of computational mass spectrometry in the R world. So some refactoring is currently going on. There is a team led by Laurent Gateau, Sebastian Gibbs, and Johannes Reiner from Bozen, Italy. And they are rewriting, refactoring a number of these functionalities. They are leaving behind some of the baggage and making that a nice basis for other packages and tools to work from. For example, on representing spectra and chromatograms with different backends to read different formats like MSPs, like MZMLs, like whatever. There's a way to have summarized information for that, that the statistics could be building upon, and metadata as well. So the entire thing is available through a website. The packages are now integrated into Bioconductor, and there's GitHub repositories if you want to check out the latest developments or provide some pull requests. Again, I said that putting together and finding all these packages was not entirely easy, and it was really Jan Stanstrup who was doing a lot of the heavy lifting behind that, and his persistence saved this from getting into the abandoned projects drawer. Wouldn't it be cool to have a catalog of software and tools that would make that easier in the future if you want to have an updated thing? I already have the review of the R-related repositories where that can be found, but maybe we have something that is even independent of R. And what I really like is that you can have links to searches and queries that would find you the software doing, for example, Metabolomics implemented in R, and the BioTools project from Elixir Europe is aiming at that. In addition, it's using bioinformatics ontology so that you can actually have a very nice controlled vocabulary about what the tool is doing with what types of data. So in summary, I think that R is a great environment for computational metabolomics. It started out some years back, and we still have the review that you can go to, have a look at that. There is a book for some update that can continuously be updated. And we think that the buzzword fair that has cropped up probably around the same time that our initial workshop is not really limited to data, but finding the software should also be possible with software as well, as I've shown with the BioTools attempt. So one question maybe to you in the audience, maybe there is some initiative to get a lipidomics, and sorry for not getting a decent acronym here. Maybe some people write a lipidomics review on some of these packages. And maybe also for other packages. Maybe there is a Python community out there that is dealing with lipidomic stuff. So again, it was a team effort with nearly 20 authors. I hope I gave enough credit to the Bioconductor and our team behind making that possible, not only for metabolomics, but all the other life sciences as well. And of course, we say thanks to all the users who are continuously contacting developers, providing pull requests on a small and large scale, and so on. So this won't stop today. We have prepared a hackathon that is supposed to be happening in spring next year. And I'm really happy if we will be able to pull that off. If you want to have a look at the slides, there is a short link here, or also just scan the QR code or get in touch with me. And with that, I'd like to say thanks for your attendance, and let's see if there are some questions and discussions we can pull off.